We want to determine whether an equation defines a function. So we could graph this and use the vertical line test if we can figure out how to graph it. But sometimes that's more difficult than just following this simple rule. If it is a function, I can solve for y. But I must solve for y remembering all of the rules and properties that we have studied so far. So if you take the even root of both sides, you have to take positive and negative. If you take the odd root of both sides, you don't do that, etc. Okay. So in the first example, I have that x is equal to 3y squared plus 1. If I subtract 1 from both sides, I get x minus 1 is equal to 3y squared. Divide by 3, x minus 1 over 3 is equal to y squared. And when I take the square root of both sides, I get that y is equal to positive or negative x minus 1 over 3. And that is not a function because that's two solutions, not one. In the second example, I have x is equal to 1/2 y squared, and you can see that we're going to take the square root of both sides again. Now, it is not always true that just because there's a y squared, it's not a function. There are cases in which the y squared would simplify out or fall away, or if there's a y cubed, the y squared is not going to be what determines the rule. So in this case, I have 2x is equal to y squared, and when I take the square root of both sides, I get y is equal to plus or minus the square root of 2x. So again, that is not a function because this is two solutions. X is equal to 2y. That means that y is equal to x over 2, right? Divide both sides by 2. And that is a function. That is the function of a line, as a matter of fact. And then y is equal to negative x squared plus 8. And that's already solved for y. So that is a function. Now, another important thing to remember when you work these is that to solve for a variable means you isolate that variable. If we're solving for y, we have a y equals, and that's the only y we have. There are no more y's appearing anywhere.